I'm Michael Isaza.
And I'm Skylar Ramaki, and we're talking about black box and white box testing.
So, a little bit of preface on the quality assurance in the gaming industry. In 1983, we had the video game crash because the hardware and the software for all the video games were not quality assured, and people just kept pumping them out. And so people lost trust within our industry until Nintendo came along with their Nintendo Seal of Quality, where the games submitted to Nintendo had to go through a rigorous QA cycle, and then when they come out, they get the Nintendo Seal of Quality so people know that these games work. And if you didn't have proper quality assurance back then, it could fail your entire system because you couldn't update your games like you can now over the internet. And so games that failed without proper testing would be E.T. That's probably the most famous one. 3 million copies came out. It was rushed in a month. There were no testing at all, and it failed, and it absolutely ended an entire generation of console gaming. So that's a bit of preface.
So, the general objective with black box testing is functionality. So, we have preset inputs, which are then run through the black box, which is our program that we don't know what the functions are, and we get our designated outputs, and we record whether or not they match, and to see if our black box program is functioning the way we want it to.
So some sort of black box techniques are the decision table testing, equivalence testing, and the boundary value analysis.
So decision table testing is when you have certain behaviors, which we call rules, that you want to emulate with certain conditions. And we take which conditions create these behaviors and which ones don't. And after we create all of our rules, we combine them with similar other rules. So we have the smallest amount of cases with the least amount of redundancy.
Mm-hmm.
And then equivalence testing is when we take each variable and the certain range for each different behavior, and we take one test case from each one at the end of the range to show that the program is changing as it should.
And then boundary value analysis is where we take the high and low test of the program, and then one random one in the middle to make sure that the upper and lower bounds of the values that the program can handle work, and then one random one in the middle also works so that we can prove that the whole range of values works within our program without having to test every single one.
So the applications of black box testing are done in our industry through directed studies, where you have certain volunteers come in and play your game, and they give you feedback on how it works. Depending on how well your directed study goes, you may end up publishing your beta for the community so you get an even larger feedback.
Mm-hmm. And we did a directed study, and they basically gave us very basic information, right, which were our inputs, and then whatever we tested, and we told them what caused the problems, which were then the outputs for the study, and it helped them out a lot.
So white box testing is where we have our designated inputs, but we also have the way the program works, so we can trace that through the source code and see which outputs we get, and then analyze that to see if it works with what we thought our source code did and what it actually does.
So some techniques that we use are stubs and drivers, method coverage, statement coverage, and branch coverage.
So stubs and drivers, also known as roots and leaves, are when you test the kind of root node, and then you also test to make sure that all the stubs or the leaves underneath that root node are also activating. Method coverage is when you check to make sure the entire thing is working with both statements and branches. And statement coverage is when you go from each main action and make sure they're all working as intended. Branch coverage is when you're making sure that you're reaching every statement that you should be.
Mm-hmm. Some applications of white box testing is to find logic errors within the code, and also to find design choices that weren't necessarily good in the beginning and reevaluate them to maybe fix them later on down the development cycle.
To conclude, in regards to game development, black box testing is the most prominent one because you can have people volunteer to come in or just hire people for cheap to just come in, test your game, see what doesn't work as intended, or see what does work.
And large groups of people can also test too. So people on the internet all testing your game, giving you feedback without them really even knowing that they're being QA testers.
With web development, with forms and feedback, equivalence class testing is probably your best bet, just because you can put in all of the values that are possible, or the range of values that are possible for each form, and make sure that every form responds as you want it to. And then for general purpose,
we think that black box would probably be the best for general purpose because it's quick, it's cheap, and it doesn't really require much on the QA person's part besides them just testing the inputs. They don't really have to look at the code and figure out what each method does, where each variable goes. They just need to input and then get an output out and then tell us if though it matches the correct answer at the end. Something like that. And that is our research project. Here are resources, and thank you.
Goodbye.